In this lecture, we will introduce indexes. There are two types of indexes, clustered and non-clustered. Their file structures are slightly different. We will also talk about routine maintenance with indexes. Indexes can really improve SQL query performance. On the other hand, whenever the content of indexed columns is updated, the related indexes will need to be updated as well. Therefore, indexes can slow down insert, update, and delete operations. Generally speaking, we will heavily index reporting applications. Reporting applications are usually read-only applications, with transactional applications such as order processing. We will create indexes on a very limited basis. Transactional applications have a lot write operations. This is the data integrity diagram. We use the primary key to enforce entity integrity. We use the primary key and foreign key pair to enforce referential integrity. If the primary key and the foreign key columns are indexed, we get very good system performance. Therefore, indexes can really help us enforce data integrity. There are two types of indexes. Clustered indexes determine the physical storage order of a table. Therefore, there can be only one clustered index for a table. On the other hand, non-clustered indexes do not affect the physical storage order of a table. We can have multiple non-clustered indexes on a table. Both types can be either unique or non-unique. Index files have the B tree or B plus tree structure. The terms B tree and B plus tree are very often used interchangeably. With an index file, there is a hierarchy of levels. We have root nodes, intermediate nodes, and leaf nodes in the hierarchy. There is only one root level for root nodes. There can be multiple intermediate levels for intermediate nodes, and there is only one leaf level for leaf nodes. In this example, we have only one root level, one intermediate level, and one leaf level. For clustered indexes, we have data in the leaf nodes. It's just like a dictionary. We search alphabetically to reach the content. For non-clustered indexes, we have location pointers in the leaf nodes. It's just like searching in the index of a book. We will find the location where the content is located instead of the content itself. If a table has a clustered index, the table is called a clustered table. If a table does not have a clustered index, then the table is called a heap. Those two terms are used very commonly. Relational database management systems have a very important component, Query Optimizer. The Query Optimizer uses the data distribution statistics to determine whether it's beneficial to use an index in executing our queries. The statistics is maintained by the system automatically. Sometimes the statistics is out of date, so our queries slow down. In those situations, we can manually update the statistics to improve query performance. Here are some best practices that we can follow when maintaining indexes. For instance, before we do a large data load into the database, we can drop indexes, load the data. After the load is complete, we can recreate indexes. By doing that, we can not only improve the load process, but also ensure that the statistics will be current when the process is complete. Also, since there is an overhead on maintaining indexes, we want to eliminate unused indexes. When we see slow-running queries, we can investigate to see whether creating an index would improve performance. With SQL programming, we do joins a lot. By indexing the primary and foreign key columns, we can improve the join performance significantly. This concludes the lecture on indexes.